Hi everyone, welcome to this lecture. So in this lecture, we will learn about the concept of conditional probability, and we will see how Bayes theorem can be used in order to find the conditional probability of an event. So this is the definition of the conditional probability. So the probability of one event given that the other event has occurred is called the conditional probability. The conditional probability of event A given event B denoted by PA given B is defined by. So this is the equation of the conditional probability. So the conditional probability is calculated when some event has occurred. That is, if we have two events A and B, then the conditional probability of event A dependent upon event B. That is, we calculate the conditional probability of event A given the condition that event B has already been occurred. So this is the way of denoting the conditional probability. We read it as probability of event A given B. So we read as A given B. So here it is probability of A given B. It means B has already been occurred. Then what is the probability of event A? So the equation is that is it is equals to the probability of a joint event divided by the probability of event B. This is called the probability of joint event. A and B that occurred jointly, what is the probability? Okay, so the conditional probability is different from the simple probability. Here it is conditioned upon some other event. One of the example could be that it has been raining for last 2 hours. Now what is the probability that the temperature is below 20 degree? It means the temperature is depending upon the rain. So this is one of the many examples of the conditional probability. Okay, let's understand these terms with an example. So during the roll of two dice, let A be the event that two faces are the same. So when we get two faces or two similar faces from a rolling of a pair of die, these are the possible values: 1, 1, 2, 2, 3, 3. Let's call it as an event A. Okay, now event B is the event that the sum of dot is not greater than 3. So these are the three possibilities that the sum of dots in rolling a pair of die is not greater than 3. So if this is event A and this is event B, so this is the joint event. Here we discuss the probability of joint event. So here I am explaining what is meant by the joint event. So we have event A, we have event B. So the event which is common in both of the events is called the joint event. So this AB is the joint event, that is 1 and 1. So joint event is the event that two faces are same and also that their sum is not greater than 3. So event A was that two faces are same, and event B was that the sum of the dots is not greater than 3. Then the joint event of these two events A and B will be the event where the two faces are same and also their sum is not greater than 3. So if I find the probability of this event, that probability will be called the probability of a joint event, that is probability of A comma B. Okay. Now, similarly, we can find the conditional probability of event B given A, and the numerator term will be the same. It is the joint probability of event A and B, but here in the denominator, now it is A rather than B. So if we go back and see equation 1, in equation 1, we calculate the probability of event A given B. Therefore, probability of B is present at the denominator of the equation. Now here in equation 2, we are going to find the probability of event B given A. Therefore, the probability of event A is present in the denominator. Now from both equation 1 and 2, if we want to find the joint probability, so these are the two equations. That is, from equation 1, if I want to find probability of A, B or the joint probability, then I have to move this probability of event B to the left side. So in that case, I will get equation 3. Similarly, from this equation 2, if I want to calculate the probability of a joint event, then I have to move probability of A to the left side. So in that case, I will get equation 4. So if we see equation 3 and 4, their left sides are same. Therefore, we can compare both of these two equations. So if I compare both of these two equations, I will get this equation. And from this equation, now I can find the probability of A given B. So I have to move this to the right side. So this equation is called the Bayes theorem. So this Bayes theorem is used to find the probability of an event given that the other event has occurred. Or in other way, we can say that this is the equation to calculate the probability of event A given event B. So here we can see that this is the probability of B given A, this is the probability of A, and this is the probability of B. So this is a very important equation in probability theory, or especially in conditional probability theory, and this equation is called Bayes theorem. Now there are the associated name for each of these four terms. So if we see here PA, this is the probability of event A, or this is the prior probability of event A. So if we see the left side, this is also the probability of A. So this is the probability of A without being conditioned, and this is the probability of A with condition. So in order to find this probability of A, we need this probability. So that's why this is called the prior probability of A, and this is called the posterior probability of event A, because we will find this later. We know this probability, and with the help of the probability of event A, we will find again the probability of event A given that some other event has occurred. So this is also the probability of event A, but it is conditioned on B. This is the probability of A without being conditioned. So this is called the prior probability of event A, and this is called the posterior probability of event A. Okay, now this is another term. So when we find the probability of event A given B, that term is called the likelihood term or class conditional probability. So class conditional probability or likelihood term is the term which indicates that how likely it is for probability, how likely it is for event B to occur such that event A has already been occurred. So this is the concept of likelihood, and this is the probability of B, that is the evidence. Basically, the probability of A is dependent on B. So this is the evidence which has already been occurred. Now it's time to find the probability of A given B. So these are the few explanation of the Bayes theorem. So I hope you understood the concept of conditional probability and Bayes theorem. Thanks for listening, and I will see you in the next lecture.